How do you determine the x and the y-intercepts of a quadratic function? In today's tutorial, I will give you some strategies on how to find the x-intercept and the y-intercept of a quadratic function. Let's have example number 1, y is equal to x squared minus 1. So in this quadratic function, we know that it is a parabola that's concave upward because a is positive. But now we're going to solve for the y-intercepts and the x-intercepts of this quadratic function. We know that for the y-intercepts, we're solving for the y value when x is 0. So when we plug in 0 to the x, we now have y is equal to 0 squared minus 1, which is also the same thing as negative 1. This means that the y-intercept is 0, negative 1. And one strategy that you can also use here is that the y-intercept is always 0, your c value for the quadratic function. To find the x-intercept, we need to plug in 0 to the y and solve for the x value. And we also learned in our previous video tutorial that a quadratic function can either have two x-intercepts, one x-intercept, or no x-intercept. So let's do algebraically. When we plug in 0 to the y, we have 0 is equal to x squared minus 1. And this quadratic equation now can be factored out using difference of squares. So we can factor it as x plus 1 times x minus 1. Using the zero product property, we have x plus 1 is equal to 0, which means that our x value is negative 1. And that is one of our x-intercept, negative 1, 0. The second factor is x minus 1. So again, using the zero product property, we have x minus 1 equals 0. And our second x-intercept is at 1, 0. So this quadratic function y is equal to x squared minus 1 has two x-intercepts, negative 1, 0, and 1, 0. And the y-intercept also is 0, negative 1. Let's take a look at the graph of this quadratic function y is equal to x squared minus 1. Examining the graph of the parabola, we know that the parabola intersects the x-axis at 2 points, at 1, 0 and negative 1, 0, which are the x-intercepts of this quadratic function. And also, the graph intersects the y-axis at 0, negative 1, which is our y-intercept. Now let's consider example number 2. Y is equal to parentheses x plus 5, parentheses x minus 1. So using the same concept to solve for the y-intercepts, we're solving for the y when x is 0. And when we substitute 0 to the x, we have 0 plus 5, and then we have 0 minus 1. So our y-intercept now is at negative 5. Which means that the graph will cross the x-axis at 0, negative 5. For the x-intercept, using the zero product property, we need to set each factor to 0. And then we have x minus 1 is equal to 0. And in this problem, if it's factored form, you can easily get the x-intercepts. If you have x plus 5, the x-intercept will be negative 5 because negative 5 will make this parenthesis 0, which means the whole thing's going to be 0. The second x-intercept will be at x is 1. So the x-intercepts are negative 5, 0 and 1, 0. Now if we graph this quadratic function y is equal to x plus 5, x minus 1, we know it's a parabola that's concave upward, and the parabola intersects the x-axis at negative 5, 0 and 1, 0. It will also cross the y-axis at 0, negative 5. Example 3, we have y is equal to 4x squared plus 4x minus 3. So the same thing for the y-intercept. If we plug in x is 0, this becomes 0, 0, and we have here negative 3. So the y-intercept now is 0, comma, negative 3. You probably noticed in examples 1 and 2 that the y-intercept will always be your 0, comma, c value. Again, the y-intercept will always be 0, comma, your c value. Since the quadratic function is in standard form, then we need to solve for the x-intercepts by factoring. This quadratic function, 4x squared plus 4x minus 3, can be factored out as 2x and 2x, that will give me 4x squared. I need to look at factors of negative 3, and when I do distributive property, I will get positive 4. So here I will be using plus 3, that way I will get 6x, and I will use negative 1, that will give me negative 2x. So negative 2x and positive 6x will give me 4x as the middle term. Now that we have the factors of this quadratic function, we can now use the zero product property. 2x minus 1 equals 0, and 2x plus 3 equals 0. Solving for x, we need to add 1 to both sides, and then divide by 2. So x is equal to 1/2, which means that the graph will cross the x-intercept at 1/2, comma 0. And for the second value for x, we subtract 3 to both sides, and then divide by 2. That will give us x is negative 3 over 2. So the second x-intercept is negative 1 and 1/2, or negative 3 over 2, comma 0. Now let's examine the graph of this function y is equal to 4x squared plus 4x minus 3. Again, this is a parabola that's concave upward, intersecting the x-axis at 0.50 and negative 1.50. It will also cross the y-axis at 0, comma, negative 3. Now example number 4. We have y is equal to 4x squared minus 12x plus 9. The same thing, we know that the y-intercept will always be 0, comma, your c value, and our c value here is 9. So the y-intercept is 0, 9. For the x-intercept, again, it's not in factored form, but we know that this is a perfect square trinomial. So we've learned that in our previous video tutorial. So this quadratic function can be factored out as 2x minus 3 square, or 2x minus 3 times 2x minus 3. Now we set each factor to 0. So this quadratic function will only have one x-intercept, and that x-intercept can be solved using 2x minus 3 is equal to 0. Adding 3 to both sides, we have 3, and that means our x-intercept is 3 over 2. So the graph will cross the x-axis at 3 over 2, comma 0. Now let's graph the quadratic function y is equal to 4x squared minus 12x plus 9. This is also a parabola that's concave up. We'll pass through the x-intercept 1.50. There's only one x-intercept because the graph is on the x-axis. Now let's have example number 5. Y is equal to negative x squared minus 4. So in this quadratic function, we know that the parabola is concave downward because a here is negative. Using the same concept, we know that the y-intercept will be at 0, comma, negative 4. Without solving yet for the x-intercept, we know that the y-intercept is 0, negative 4, which happens to be the vertex as well. And the graph is concave downward. So what do you think will be our x-intercepts? Right, let's explore that algebraically. Solving for the x-intercepts, we have negative x squared minus 4 is equal to 0. which is the same thing as negative 4 is equal to x squared when I move negative x squared to the right side. Now we need to get the square root of both sides. When we get the square root of both sides, we will have square root of negative 4, which is imaginary. You cannot get the square root of negative numbers. So if we look at the graph, this means that there is no x-intercepts, which means that the graph will not cross the x-axis. Now let's verify this conclusion that there is no x-intercepts. Let's graph the function y is equal to negative x squared minus 4. And yes, the parabola will not cross the x-axis, therefore there is no x-intercepts. So just to summarize, there is always one y-intercept for a quadratic function. For the x-intercepts, it is possible to have 2, 1, or no x-intercept. Again, to solve for the y-intercept, we substitute 0 to the x and solve for y. When solving for the x-intercept, you plug in 0 to the y and solve for x, either using factoring, square root method, completing the square, or quadratic formula. Thank you, and hope you learn how to find the x and the y-intercept now. Thank you for watching, and I hope that you learned something from me today. Please send me your suggestions and feedback to the comment section below, and help me achieve my aspiration to reaching out to more learners around the globe. Thank you, and don't forget to subscribe.